So without any further ado, let's just begin. Yeah, by the way, uh, tomorrow is your exam, right? Just raise your hands if I mean, if one or two people, if they can, yeah, okay, okay. So, how's the prep? Good, okay. Hey, okay, okay. Whosoever has raised their hands can lower their hands now. I just wanted to know. Yeah, and apologies for last time. The last video that I had uploaded, it didn't have my audio. I have mentioned that in the comments as well. So uh, I have written some parts in the description actually, so that will be a little helpful. But anyway, today for the first I think 5 to 10 minutes, I'll just cover that second problem again, okay, where we that note change or coin change problem that was it. Okay, wait, I'll just share my screen if that is a okay. Just a minute, I can't hear any one of you because I have mute. Just yeah, you yeah. I think Sakshar Das was saying something.
Yes, sir. I was saying that, sir, tomorrow are we going to get programs for solving?
So what is the time limit that you have been given?
So we have got 3 hours time limit. Mine
See,
is afternoon session. It is from 2 p.m. to 5 p.m. And
yes,
some also have a morning session, so 9 to 12 a.m.
yeah, okay, 3 hours, right? So see, you'll have MCQs, you'll have fill in the blanks, you'll have, I mean, fill in the blanks as in, I mean, either let's say they have written a code snippet like you have had in your assignments and all, and you have to just give the output or whatever. I mean, you have done the assignments, right? So it will be
Yes, sir.
similar to that. And related to the programming part, I'm actually not sure if they'll ask you to write a code. See, because how much can you do in 3 hours? I mean, yeah, you can write a small
Only
code in three
interpreter
hours.
will be provided. Interpreter.
Interpreted, I don't think it will be provided. So
Interpreter won't be provided, but for those specific cases where we have to write a little bit of code, there'll be only an input and output, but there'll be no interpreter.
I think scientific calculation will be provided for do the certain calculations, sir. If I'm
Sir,
not
I
wrong,
I
also
it
don't
was already
previously,
I
sir, I
mentioned.
don't
have
think any
previously
calculations are
participated
necessary here.
in. Yes, sir. So I actually previously participated in other NPTEL exams, means related to computer domain, and in those exams, sir, we are actually means our keyboard is actually locked. So means the only thing which we can use is the mouse. From the mouse only we have to enter the credentials, our password, and everything. So means if the programs are given to be written and the keyboard is locked, then how are we going to write the codes?
Yeah, yeah,
So
see,
that's an
no, no,
important
see,
question.
if at all you have to write a code, then the keyboard will definitely not be logged. Okay, if at all you
Okay,
have,
then sir, this is an exception.
yeah, yeah, see, if you have to write a code and the keyboard is logged, then there will be an uproar, right? I mean, you can't just go on using the on-screen keyboard and typing one after the other, etc., etc. Okay, okay, let's. It's already 6:07, so let's just get to the class. I request everybody to mute themselves, or wait, I see if yes, yeah, yeah, okay. So
Just one question from my end, which is that is there any separate program as programming assignment for the exam? It has not been given till now, uploaded till now.
yeah, no, no. See, whatever is there will be communicated to you, and since it has not been uploaded, you can rest easy. So,
Okay,
see,
fine.
basically, you have done the normal assignments, right? So they will be there,
Okay.
and in terms of programming, they might ask you to write one function. Okay, so just one function, and you know, right, how they check the function that you write as part of your programming assignment.
Yeah,
Yeah, so
yeah,
they
yeah,
have
that.
a set
Yeah.
of inputs. So they,
Uh,
if they get the desired output, then that's what is right.
so the input format and the output format both should match, right? what they are expecting?
Format, no, no, see, format is, you can input a number and get a string. So format, you don't worry about format, but they would mention that what is the output format and input. See, what is the input format they will give, and output format that they expect. Okay, so they will mostly mention, not mostly, if they are, yeah, see, there can't be any there can't be any ambiguity right here. So because because I think some 20,000 or 40,000 people will be writing the exam. So
Sure, okay. So
Okay,
basically,
sir.
the
One question from my side.
yeah.
Sir, actually, sir, I want to know a sample paper. I want to see a sample paper if you can provide in this session.
What I can't, you're not very
Sample paper.
scientific paper.
Sample
He's asking
paper.
for a sample paper.
Sample paper, sample paper,
Yes,
no,
sir.
I don't have with
Yes,
myself.
sir, please.
No, no, I'm not joking. I mean, I'm not lying. I actually don't have the sample paper for all that. And see, the pattern also slightly changes every year. Not every year. I mean, not. I mean, just slightly. So if you can get in touch with anyone who has attended this previously, then I think. See, if you've done your assignments well, then I don't think there should be much of a problem. And the final score that you get, the weightage for the assignments that you did, they have quite a good weightage. Okay, so if you scored the previous year paper, okay.
Okay, sir. Only by the assignment we can get a score.
I mean, I hope you have watched all the videos as well. I mean, the actual content of the course.
Yeah.
If you've
Yes,
done
sir,
that,
I have
then
one.
yeah, if you've done that, then I think you can score well. So just all the best for the exam. Let's just, without any further ado, let's just go to the uh, see exam outline. I can't exactly provide. See, NPTEL has to do all that. Blue. Oh my God. It's see, it's I can't give you specific that these number of number of MCQs will be there, and these number of multiple correct questions. See, and there can be some questions where more than one option is may be correct. So even that is possible. And yeah, so someone has shared a link in the chat. So request everyone to just uh, see this, okay, this link. If I mean, just copy it and can keep it somewhere. And I mean, my okay, yeah, just copy this link and keep it somewhere, and once this session ends you can just have a look. Okay, so let's just begin the session. I'm muting this tab for now, so if you say anything I'll not be able to hear it, but the fellow participants will be. So okay, just for your information. Okay, I hope you can see my screen. So welcome to the ninth and the final live session for this course, Programming Data Structures and Algorithms using Python. So this is a concluding course. So last time we saw that I had given you guys a task to do. Okay, so it was a program that you had to write, a function that takes in two parameters. So two parameters as in one list and one integer. So it's like I want to, so it's called the coin change or the coin change problem or something. So we take in the possible values of coins we have, or you can also imagine notes. Okay, so notes in an ATM machine. So when a combination is not allowed, I mean, if I have only 200 and 500 rupee notes and I want, let's say, 300, then it says please choose a valid amount. Since I can't make 300 with just 200 and 500 rupee notes. Okay, so it's something like that. So you are the ATM machine and you have to give the minimum number of notes here. Okay, so instead of notes, let's just work with coins here. So the denomination of the coins is there. So you have to what is the minimum number of coins required to give this value. Okay, so here it's 12. So for an example, input here is 125, right, and 12. So it means I have a bunch of 1 rupee coins, a bunch of 2 rupee coins, and a bunch of 5 rupee coins. What is the minimum number of coins that I'll need to make 12? So the answer that I should get is 3, because 12 I can make with 2 5 rupee coins and one 2 rupee coin. So this we already discussed in class last time, and I also wrote the code for, I also explained the code to some extent for you guys. And then part 2 of this task was I want the minimum number of coins needed, and I also want what coins I'm using. Okay, so this I had written the code last time itself, but I think some of you didn't understand it very well. So I'll just go through the code from the start. So here I am using dynamic programming. Okay, so I can do this without this, but that will actually it will make me work a lot. I mean, it will make my code will be, first of all, slightly longer. It's called a naive implementation. So naive as in I don't know much. I'm just working with what I know, just the basics. So I'll have a very long code, and then I will just it will take a lot of iterations. It will store unnecessary things, etc. etc. So there will be recursive calls, this and that. So that is why to make it faster, to reduce the time order. So I think in one video when we see the efficiencies of codes, we see that how many operations it is performing. Okay, so that order. So here this thing was the problem was this. So we have a given number of coins, let's say that is 125. Big stacks are there. Okay, so unlimited amount is there for this, and I want to make 13. So to 13 I need 2 5s, 1 2 and 1 1. Okay, so yeah, 13 I can also make with 13 1 rupee coins. Okay, so that is also an option. So but that is not the minimum thing, right? I want it to be minimum, so that is 4 here. So I'll just explain the code right away. Okay, okay, sorry. To write a code without errors, yeah, you have to know how to debug. So one tip about debugging, I'll just show in this code itself. Okay, so I'll share my screen. Okay. Yeah, I hope you can see my screen. So yeah, the program I have written here is called ATM1. Okay, so last time we went through this first one where I only want the minimum number of coins or notes. Okay, now I'll just so now I have modified this code to get more than one. I mean to also get what coins or what notes I'm using. So yeah, so one way to debug the code is just, or if you think that where can the issue be, just print it. Okay, so just use print. That way you will know that what is going on in between the code. Okay, so if you are updating, let's say, a list or a table to store values, and if you think that the output that you're getting is not correct, then just wherever the updation is taking place, just next to that next line, just use print. Okay, just print the table or or the list, or like, or whatever. So table is actually a list here. Okay, so so that way, I mean, you will get more output, but you will get a lot of values as output, but you can actually see that how the progression is going on and where the mistake might be, or where the error is, etc, etc. Okay, so I'll just so this code is what I already wrote last time, so I'll just go line by line, and then I'll also give you some practice questions that you can solve. Okay, so so this DP is my table. Okay, so for in memoization and dynamic programming, we need to keep something like a table where we store the values. I mean, so that we don't have to reach back, or sorry, we don't have to calculate the same values again. I mean, I am sure that you have gone through the lectures, the video lecture, so I'll not yeah, sorry for the slight lag. Okay, so I'll actually unmute you. So if you have any doubts in this one, you can stop me. Okay, if you have any general doubts, then just hold it to after, like, once we are done with this. Okay.
Would you make the font bigger?
Yeah, sure. Okay.
Thanks.
Okay, so yeah, so in this, what we actually do is, if let's say my amount is 13, so I'll make a table where I store the minimum number of coins required from 0 to 13. Okay, so all of it I'm storing. So and you'll know why, and that is what dynamic programming is all about. We store all the preceding things. So if I want the 10th number of the Fibonacci series, I'll store 1 to 9, sorry, I'll store from 1st to 10th. Okay, so because 10th, it depends on 9 and 8, 9 depends on 7 and 8. Okay, so it's like that. So since that dependency is there, we need it. Okay, so we need to since it's all yeah. So because of that, we needed to I mean, we need to store those values as well. So yeah, so first,
how are you fixing the number of entries in this DP table?
yeah. So so like I said, number of entries is the value I want. Value I want, as in, if my input is 13, I mean, I want the minimum number of coins required to get 13. So see, notes is what all notes I have. So I have 100 rupee. Okay, so it's basically the coins. So I have 1 rupee coin, 2 rupee coin, 5 rupee coins. I can also change this. Okay, as my input, and this amount is basically what amount I enter in the machine. Okay, so if I entered 13, so 13 is what I want, and that too in the minimum number of notes or coins. Okay, so I have so see, this is basically a list with 13 entries. I have done amount plus 1 else. So it's sorry, so actually it will have 14 entries. Okay, so 0 to 13. That is why I have written this thing plus 1, amount plus 1, and I'm writing this flow. So yeah, this thing is a way to write infinity. So you can't just write inf, you have to mention if it is an integer or a float. So float, so this is the symbol that we use for infinity. So just keep that in mind. So I have set for 0, if I input 0, then I don't need any coins, okay. So the 0th place, or actually first place, okay. So you know that in Python, since we start with 0, so the first element that we see in a list is actually the 0th element. That is why, say, index, okay. So so that is why this 0th index is 0, because to get 0 we don't need any amount. And I have also mentioned that if the criteria is not met, I'll just write -1, okay. So I'll just this notes used is what this note used is just to say that if I'm using that note or not, okay. So if I want 11, I'm storing it in a way that if I'm using 1 rupee or not, or if I'm using 2 or not, if I'm using 5 or not, like that, okay. So this, and also I have initialized this as all -1s, okay. So just it's just an initialization, so you don't worry about this, why it is -1. I can also take some other number, some very small number. So since -1 is less than 0, I didn't want to write 0 0 0 0 0 again, so I just wrote -1, okay. So now notes is what my input is, first input is, that is in this case I have also written one what is that called, one sample thing, sample input, okay. So I have mentioned coins here. So yeah, one more thing, it's called notes here and I'll use notes here, but if I pass this as coins, okay, so here I have written coins and I've passed this as the first element, okay. So it will just say that, see, it knows that this notes is a list, okay. So notes is a list and amount is an int, so it will not check the name, it will just see if it is a list or not. If it is a list, okay, it will pass. So this coin, once it goes inside the function, it will work as this notes, okay. So that's also one thing. I mean, see, because if you get a question tomorrow that uses different variables in the function and in the input, then you should not get confused. So you just keep note of the index. Yeah, if you want to flip the index, you can also write this here. So I can write notes equals coins or something like that, okay. And that way I can write amount first, and but for that I'll have to write that for both the inputs, okay. So yeah, so then what we do is yeah, so now we scan through it, okay. So first so this for note in notes, as in this notes is a list, and I'm starting with 1, then 2, then 5. So first I'll assume that I have only 1 rupee notes, okay. So with that this DP, actually most of you weren't there in the last class, that is why yeah, and there might be some negative marking.
May I suggest something? I know you're trying to show this code, but if you'd show us in with this thing side by side, what do you call that? The debugging, then we'll know exactly what's happening.
Debugging as in the
as in if you put the debugger on the function and call it, and then in the side there'll be all the values, right? Instead of reading it and then trying to visualize it, it'll just be in the side screen.
Oh, right. So what I'll do is I mean, actually, since in I think Jupyter I can get those values side by side, but since I'm using Google Colab, what I'll do is I'll write the print statement here, okay. So I have used a print statement here, and then you will see that what is actually going on here, okay. So I'll also write DP here, print DP. So now you can understand what is going on, okay. So So yeah, so one thing, now because of this you don't know which is which, right? So I'll have to change that. What is the input?
Sir, could you copy paste the code in the chat box?
Copy paste the code in the chat box. Yeah, wait. Okay, yeah, why not? I have also put, okay, so here the sample input is 5, okay. So I have pasted the code here.
Thank you, sir.
Yeah, others, please don't write anything. We need the code.
Yeah, so yeah, let this be the last message for now, and then once we are done with this, yeah, you can actually copy this and paste it on your own collabs, but okay, anyway, or whatever platform you're using for this. So yeah, so yes, I've also written some comments here to make it more clear, but very few of them. So see, yeah, one more thing is if I write 3 quotes, the whole, see, hash means only that line gets commented. Three quotes means whatever is below it will get commented, and to close it I'll have to write 3 quotes again. Okay, so commented means the interpreter will not read it. That's all.
You might have to give everything from if dp amount. Go 2 lines below, yeah, because that has not come out. 2 lines below.
What?
If you go 2 lines below from that, if the amount from the table is not equal to that didn't come up in the chat.
Oh, that didn't come up in the chat, huh?
Mhm.
Oh God.
No,
Hey,
it's
wait.
okay. It's just from what we didn't get is from the
Yeah, right. Yeah, I saw it.
So
Yeah, I saw it. So I'll
in the
just,
end, what I need is just a TP, and if you can give, yeah.
I'll just. So yeah, I apologize for that. I didn't actually see that.
No, it's okay. If you just keep explaining it, I'll run it in my debugger and see exactly what's happening.
All right. Oh yeah, see, copying it directly from there actually it. Okay, so till where is it getting printed? I think the whole thing got printed, right? Yeah, the whole thing got printed. So I don't think, yeah, that should be an issue now. So okay, I'll quickly go through it. So see, first I have only one. So let's just work with values here. Okay, instead of just using variables in air, let's just work with values. So here notes is basically 1, 2 and 5, the list. So first I am scanning the list one by one. So first is 1, then is 2, then is 5. Okay, so first it's 1. I have entered the for loop with 1. So for I in range, note to amount plus 1. So I have written amount plus 1 here because I want to stop at amount. Okay, so that is what Python does, right? If I write n, it will start n, it will stop at n minus 1. So that is why I wrote amount plus 1. So I just want to see that how many nodes I need to make that particular amount. So now I have only 1 here. So the note is basically 1. So I am traversing from 1 to, I'll just change it to 13 because 13 is, yeah. So I am traversing from 1 to 13, right? So my scroller is also slightly, yeah. So see, here with 1, I'll simply get 1 for 0, 0 nodes, for 1, 1 node, for 2, 2 coins, 3, 3 coins, 4, 4 coins. Okay, so to make 13 with just 1 rupee coins, I'll need 13 1 rupee coins. So just so just this first loop with 1 is just that. Okay, second loop is where this actually comes into place. Okay, so now I have 2. So now note has become 2, and this I am scanning from 2 to 13. Okay, I am not scanning 1 because I can't make 1 with a 2 rupee coin, right? and if I have a 5 rupee coin, I can't use 5 to make something which is less than 5, correct? So then what I do is so now I have 2, okay, and let's say we are at 7, okay, so I'll just write it in comments. Let us say we are at 7. Current value is 7 because we are using 7 1 rupee coins. Okay, so now we have 2. Okay, so actually I can't. 7 is okay. So you will understand this with 7, or let's just say 2. Okay, so the current value is 2 1 rupee coins. Okay, so that is my DPI now. So now I'll check if DPI minus note plus 1 is less than DPI. So note here is 2, right? So if I use a 2 rupee coin for 2, I am left with 0. So this will become 0, and this plus 1 is at, because I am counting the 2 rupee coin as well. Okay, if it is less than
So one question over here. So the note in the note variable, it's iterating over the notes list which you passed, right?
yes, yes, yes.
So the notes list is 1, 2, and 5, right? If I
Correct, correct,
remember.
correct.
So if we are in the second loop of the notes variable, or like of the notes list, if we are in the second variable, so we are starting from
See, in
that
this loop, see, I think, do you mean this a mini loop when you
the
say
inner
second
loop.
loop?
Yeah, the inner loop. Say
Inner.
suppose we are actually, so first is for note in notes would mean like first you'll start from 1, right?
Correct.
In the notes.
Yes,
And
yes.
then in the inner loop it will start from 1 till amount plus 1, whatever
Correct.
is amount plus
Yeah,
1 from
yeah,
that
yeah,
image,
yeah.
right? So if that is the situation, then what does this dp1 I minus note? So
Yeah,
say
yeah.
suppose
So,
1
so
minus.
wait. Yeah. That is what I'm getting to now. Okay. So, if I explain with 2, then I'll also explain with a larger number so that you get a little more clarity. Okay. So see.
1 minus, okay, sure, okay.
So see, DP is basically my table where I store all the minimum number of coins that I need for from 0 to 13. 0 is also there, so the 0th entry is 0 since I don't need any coins to make 0. So see this, I do I minus note because let's say I have given one I, okay, sorry, one, I think 3 would be better here, okay, so I am saying 3 here. So the current value with 1, it was 3 because I need 3 1 rupee coins to make 3. Now I am iterating with 2, okay, so now the note value is 2, and this so what I do with 3 is I give one 2 rupee coin, right? So now I am left with 1. So now I'll go to my table and check how many coins I need to make 1. So that is what I'm doing here, okay? So 3 is here, so 3 minus 2 is 1. So since I have one 2 rupee coin there, now I don't have to check for 3, I have to check for 3 minus 2, and that 2 rupee coin that I have is 1 here, okay? So since I gave that one 2 rupee coin is there, okay? So now 3 has become 1, right?
What was the initial value? So sir, this
3
dp
3.
dp itself changes with the loops, right? The content of dp
Yeah,
changes
yeah,
with the loop.
yes. The content of DP is a set of array or a table where I'm storing the minimum number of coins required for all the numbers till my amount. Okay, so if my amount is 13, my DP will have the minimum number of coins that I need from 0 to 13. So even if I want the value of 11, 12, whatever, I can get from DP. Okay.
So every position in DP is storing the minimum number of amount, is it?
Yes,
Minimum number of
yes, for that particular number, okay, that particular index, fine.
So say suppose here what does note means then? So how do you interpret note over here? So in note means like how many such coins would be required to fill up that particular
No,
position?
no,
Is it?
no, 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 no.
Uh,
Note is basically only the note like 1, 2, or 5. That's all note is. Note is my list with 1, 2. Sorry, notes is the list with 1, 2, and 5. And so
yeah.
note can take the values 1, 2, or 5 according to where we are in the for loop. So the first iteration, note is 1, then it became 2, then it became 5. Okay.
Correct, right. So when we are iterating over DP for every index, what is the relevance of node then over there? How do we like fill up that particular index with that minimum number of
Yes, that
nodes
is what I'm.
of the
So
denomination?
yeah,
Yeah.
yeah. So that is what I'm uh, telling you, right? So first,
Okay.
so if I'm, let's say if I'm at 3, right? I was just trying to explain with an example. So let's say
Yes,
I'm
please.
at 3. So from the first loop iteration, I have mentioned that, see, one side, see, when I run this first, this bigger loop, note is 1. So my table would be, my DP would be 0, 1, 2, 3, 4. I mean, see, because if I want to make 8 with just 1 rupee coins, I'll need 8 1 rupee coins, right? There is no minimum or maximum there. 8 is the number that I need. So I'll just save that, okay, I need minimum 8 coins to make 8. So that was 1. So that list is already there, okay? So I think print DP inside this for loop, right? So wait, I'll remove this. I'll remove note used here because this is confusing. I'll run this. I'll show this from this. Yeah, actually it is helpful when I. So just keep that in the side. Okay, I'll so do this.
Take a screenshot of the result answer and put it in the site. I think
No,
that
no,
would.
yeah. Instead of doing that, I'll just do this, and I'll just comment it. Okay. Yeah, I think this should work, right? So see, first I have 1. Okay, so first note is 1. So I need 0 1 rupee coins for 0, 1 1 1 rupee coin for 2, 7 for 7, 13 for 13, etc. etc. Okay, then I have 2. So 2, I'll of course start from here, right? I'll start from 2 because I can't use 2 to make a 1 rupee coin. So I can't use a 2 rupee coin to make 1. So that is why I'll start from here. Okay, that is so when I reach this, I'll do this. Okay, so if dp I minus note plus 1 is less than dpi, so dp I minus note is what, 0, I mean dp of 0, that is 0, plus 1 is 1. So see, this I minus note I am doing because from 2 I have removed the 2. Okay, so this 2 is getting confusing again. So I'll just take one index, let's say 5. Okay, so 5 was 5 here, fine, 5 was 5 here. So now when I've reached 5, first I'll say, okay, so how many 2 rupee coins do I need to make 5? So first I give one 2 rupee coin, right? So now I need to make 3, fine. If I use one 2 rupee coin, what I am left to make is 3, and 3 by this table I already know that I need 2 coins. So right, 1 2 and 1 3. So that is what we'll do at every step. We'll see that how many coins that I need. So this 5 minus 2, so dp3, right? So dp3 is basically 2 here, right, in this table. So this table is getting updated at every stage, and this plus 1 is because, so I need 2 coins to make 3 and one more 2 rupee coin to make 5. So that is a plus 1, and I'll compare and see if it is already less or more than whatever we have, then I'll replace it. If it is less than what we have, I mean, so since 3 is less than 5, I'll just replace it. Okay, so that's what I'm so dpi is now dpi minus note plus 1. Okay.
So if the first value is not 1 instead of 1, if you have something else
Yeah, sure.
in the first value, then
I can do that. Yeah, I
no,
can.
no. What I was asking is that in that case, like, say, suppose in the first iteration we have 0, 1, 2, 3, 4, 5, 7, 8, 9, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 entries with each of those, because we have had one, right?
Yes.
We had one. So dp I minus naught. So initially it was infinity, correct? Right? Initial
Initially,
values,
yes.
it was infinity.
All these values are infinity.
Infinity.
So
Okay.
I'll
So dp1
come to
minus.
that
Okay.
where we.
I'll have to go through it once. Anyway, sir, you can continue, please.
Yeah. For to keep track of time and also and to hold other participants' interest. Okay. Sorry, keeping their interests as well in mind. Okay, so yeah, finally one more exam. So now we will go to 7. So 7 was 7, okay, with 1. So now I have put one 2 rupee coin, put forth one 2 rupee coin. Now I have to make 5. So what dynamic programming helps us is, since I have already stored the value in the table. So see, if I didn't store it, then I'll say 5. Okay, so 5. Okay, fine. I'll put one 2 rupee coin and check. I'll see 3. 3. Okay, so 3 is more than 2. So I'll put one more 2 rupee coin. Then I'll go to 1. Okay, so 1 only one coin. So 2, 2, 2, 1. So 4 coins. So I'm not doing that, since the minimum value of coins required to make 5 is already stored in my table. I'll directly access it. Fine. So this is stored here. So I'll access it and I'll say, okay, fine. 3 plus 1 is 4 and 4 is less than 7. So 7th entry becomes 4. So that way. Okay. So now let's go to the next loop. So 5. So now note has become 5, and for 1 to 4 it will remain unchanged. Whatever we got after the second pass, it will remain unchanged, because of course we can't make 4 with 5, right? So now 5 is there. So I have reached 5. So what I do is, since so yeah, it will not even enter this, right? 1 to 4 will not even enter. I am just starting with 5, so I am only traversing from 5 to that 5 to 13. So 5 is the first entry. So I'll do 5 minus 5, that is 0, and I know from this table that dp0 is 0. So and since 5, I'm using one 5 rupee coin, so plus 1. So and I've seen that 5, so 1 is less than 3. So I'll replace this with 1. So like that I can go to the whole thing and I can actually solve it. Okay, I hope this logic is clear, and how to get the minimum number of coins. Yeah, of course. Also, okay, so what I'll do is, there is 3 here, right? Amount is 13. I'll make it 3 and I'll remove 1. Okay, can we make 3? No, we can't make 3. So I'll run it. It will say okay, so not possible. That's what it said, and this whole thing got printed for some reason. So I'll just remove this since this part is done. It says not possible, and it says I need infinity. Okay, so 3 is like what, 0. So it's not possible is what it's saying. Okay, so I'll show that part of the code as well. Okay, yeah, 23, why not? So once I'm done with this, once I got the minimum number of coins, I'll exit the big loop. I'll come here. Okay, so I'll say if no denomination is possible, that means dp, some of the dp values didn't, the last dp value didn't change its value. So sorry, the last dp didn't change its value. It's still float in, right? So I'll say if that's the case, then return -1 and also return one empty list. So this list is, I'll get to that list. So this A list is basically the actual number, the actual coins. Okay, so if it is 13, then the actual coins will be what? 5, 5, 2 and 1. So 1, 2, 5, 5. Okay, so the list here is empty. So now if this is not the case, okay, so someone has turned on their mic and
Just
so
one question.
yeah.
Why is DP amount? Why should it shouldn't be DP amount plus one?
No, it should be only DP amount.
DP amount means it would be the 13th amount, right? That means that you're trying to go to the last index in the loop. The last index is okay. No, last index is 13, right? It starts from 0 to 13.
Exactly.
Okay, so yes, correct.
Right. So 13 is basically what, 14, right? So,
Yes.
Yeah.
So you are anyway skipping the first index, right, of DP. DP0 is not at all calculated, is not touched, right?
Yeah, it's not touched. I'm just seeing that DP0 is 0 because I know that for 0 to make 0 I don't.
No combination will work.
No, not no combination will work. I'm saying I don't need any coins to make 0.
Correct, right.
Yeah,
So whatever is the number in the nodes list, it won't work for 0 because you can't
No.
add.
See. It's not like it will not work. It need not work, right? I don't need any coins at all. So the combination. So it's basically 0 into x plus 0 into y plus 0 into z. That's
into
all.
Z, yeah.
Yeah. So it is. So it's not. It's you. It's not saying it will not work. It will saying it's just saying that it need not work. Okay. So that's what. Yeah. So now this note used. I've just it's just I'm trying to store if I've used that note to make that amount or not. Okay. So note used is basically just I'll print this actually. So I'm removing DP from the output and I'm printing this. So you can see that 0 is all zeros. So it's just 13 ones, 13 twos and not 13 twos. So from 2, right? So 1 first is 1 and then rest twos, and when and in the final pass it is -1 1 and up to 4 it is twos, then up to 13 it is fives. So I'll tell you why I use this. Okay, so I want the coins I need. Okay, so so my final table is this. So what I'm doing here is, so I'll just copy this, see, paste it, parallelly we'll see that how it works. Okay, see, so while amount is 0, so of course it's else if it is 0, then I'll just jump to this line directly, right? So amount, I mean, of course. So while amount is 0, I'm saying use notes. So yeah, I have created one more. So notes used is that this long table. It just says that I'll need these notes to make that. Okay, that's all. Don't break your head. Don't break your head over this. Once I explain the while loop, it will be more clear. So this use notes, I am initializing it as an empty list. Okay, to store what all numbers I need. So let's say we need 13. Okay, so I am at the 13th spot here, right? So while so use notes dot append. So I'm sure you know what is dot append and what is the difference between dot append and dot extend. Okay, so appending is when I append one non-list value to a list, so just one single value. Okay, extend it when I want to extend a list with a list. Fine. So yeah, so note used amount. So amount is the index. So 13th index here is 5. So 5 has been appended to it. So 13 minus 5 is what, 8. Okay. So since 5 is already there, now what I need to do is make 8, right? Because 13 minus 5 is 8. So I'll go to the 8th index here. So that is what I have done here. I have written here amount minus equals note used amount. Okay. So so I am subtracting from my amount whatever note I already used. So now amount has become 8, right? So amount has now become 8. So 8th entry is also 5. So 5 has been stored here. Okay, so I am actually working with 23, okay, not 13. So 23 minus 5 is 18. My bad. So 18. So first I check 23rd place, which is 5. So now to check place 18, that is also 5. Now 13, that's also 5. So 13 minus 8 is 8, that's also 5. 13 minus 5 is 8, and then 8 minus 5 is 3. So 0, 1, 2, 3. Right, 3 is here. So I'll put the 2 here, right? Because to make 3, I can't use 5. So 2. So the third place is 2, and then 3 minus 2 is 1. So 1. Okay. And since I wanted it in an ascending order, I just use this thing. So I get the output basically as 5, 5, 5, 5, 2, 1. So to flip it, I'll just use this. To flip a list, name of the list, and this thing. Okay. So square brackets colon minus 1. Okay. So just keep that in mind. So that is how I get the actual denomination that I'm using.
So say suppose 23 in this case is the amount which we want to reach, right?
Correct.
So can you just print that notes used? Yeah. So notes used. So
Now it is 14 now. Okay.
yeah, now it's 14. Yeah, understood. So now it's 14, and you are saying amount equal to amount minus note used amount. Right?
Correct.
Note used amount. Okay. Note used.
You know
note
what
used
this is shorthand for, right?
Which one?
This.
Yeah. This is the assignment operator. Yeah.
No, this,
Yeah. So this subtracts amount equal to amount minus note used amount.
So whatever is there in the note use table at that index, it will just subtract it from the amount. Okay. So basically, I need
So
a table.
amount starts at 14. Amount starts at 14, right? And then
yeah.
you move till it is
1.
not reached.
1 or 0. Yeah. 1 or 0.
Yeah. It's greater than 1. Okay. So amount equal to amount
Greater
minus,
than 0, not 1.
Yeah, greater than 0. Greater than 0. Positive. Right.
So if I have a so let's say I have 14. So once I reach 2 here, it will do 2 minus 2, that is 0, but then it will not enter the while loop. Okay.
Correct.
So
yeah.
that is why I'm not I'll not be reaching this minus 1 that I started with. Okay. So I think this is
note used amount, amount equal to amount minus note used amount, which is okay. So
and one more thing, to basically get this table, I use this. So you can also you can get this particular list or table using a lot of operations. Okay, it's basically minus 1 at 0th position, 1 at first, and 2 up till 5 and 5 up till end. So if I change what coins I have, let's say someone came up with a 3 rupee coin. Okay, then what happens? So then this table will also change, right? So now I have okay, so this table has somewhat changed. Yeah, see 4. Okay, so 4 you don't use 3 rupee coins at all. It's just 2 plus 2 or 3 plus 1. Okay, so see here in this one, it says that if it is strictly less than 1, since 2 and 2 are equal, it will keep it as 2 plus 2 and not make it 3 plus 1, but both 2 plus 2 and 3 plus 1 will give me 2 only, I mean sorry, will that use only 2 coins will have 4, right? But since I'm saying that it is but since 2 is not strictly less than 2, I'll just keep the it will not enter this this if condition itself will not get satisfied, and it will just remain as 2 plus 2. Okay, so that is why, so if the note is not used here, I'll not replace it with that number. Okay, and that's what I'm doing here. So if I'm using the note for that particular amount, then I'll say okay, then I'll just change the thing. Okay, so this table is basically saying that I need this final table, I need 5 to make, so I have this thing here. What is this? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is what? 3 plus 3 plus 3, right? So I'm not using 5 here. Okay, so with 5 I can write 5 plus 2 plus 2, right? 5 plus 2 plus 2, or 5 plus 3 plus 1, that will also yield 9. But 3 plus 3 plus 3 also uses 3, and since it's not strictly since 3 is not strictly less than 3, this will remain as it is, and the thing that we need for 9 will be 3 3 3 and not so I'll just change it to 9.
So basically, note used is changing for every entry in the notes, right?
Yeah. So basically, note use just says that if that entry needs what is the highest coin or the highest note that you need to have to get that entry. Okay, so highest thing I need to make 9 is just 3. I don't need 5. I can have 3 3s and be done. But to make 8, I need 5. I can't have what is that called? Okay, so if it is 8, I can't do it with just 3s. Okay, I need 5 to get 8. I can't use just 3s and 2s. I mean, yeah, I can use 3s and 2s, but then I'll not have the minimum amount, right? So 2. So 5 plus 3 is 8 here. So 5 plus 3 is 8. So first I say 5. Okay, so 8 minus 5, that is 3. So now I've reached 3. 3 minus 3, 0. So 3 and 5 are printed. Okay. So I hope this was somewhat clear.
Yeah, actually the note used is, I mean, the second for loop starts from the entry itself and moves till the end of the DP allocation, right? So
Exactly, and the reason for that, like I've mentioned, is just that you can't make a smaller amount with a bigger coin. That's also I can't make 4 rupees with a 5 rupee coin, right?
Correct.
That's
exactly.
so I don't even need to look at it. That is why I just start from that point. Okay.
Not the logic.
Yeah. Okay. Fine. So.
But I have to check the statement which you wrote over there. A DPI minus note plus 1. So once I'm okay with it, I think rest is fine. Thanks.
Okay. Yeah. So the code is there in the chat, so you can. I mean, instead of typing it out yourself, you can. And see, if you are not able to directly paste it on, I think you will be able to directly paste it on Colab. But for some reason, when I copy from presentation, I'm not able to paste it on Colab. Okay, so I'll go to the next segment of this. So this is done. So these questions you might have seen in the in your assignments. Okay, so just to revisit them, I chose a couple. So yeah, it's also called questions similar to assignment questions. Okay, so this function definition in place. Okay, I'll just have muted the site again just for your information. Right. So this is what I'm saying. I'm saying pairs is a variable x y for x in range 7 1 minus 1. So 7 to 1 in steps of minus 1, and for y in range 3 1 minus 1. If x plus y modulo 3 equivalent to 0, then return the output. Okay, so pairs. So this modulo is basically the remainder sign. So who can answer me? So if one of you can just unmute yourselves and tell me the answer for this first one. Okay, so sorry. Yeah. Now
Yeah,
please
go ahead.
go on. Shush.
X will be, yes, sir. X will be 6 and Y will be 3 first, and it will be minus, and here plus divide by means 9, and first will be 0, so it will be true, sir, if I'm not wrong.
Okay, fine.
And then 5.
So wait,
5 will be
I will actually start with 7. Okay.
7 plus
So wait. So first entry will be
7.
7 and 2, not
7 and 2.
3.
First entry is
7
7
and
and
3.
2.
7 and 3
2.
is 10. 10.
7 and 2, sir, because
Correct. Okay.
7 plus 2, 9. 9 is divisible by 3.
It will start from 3, no, sir. Why?
Next will be 6, comma 3.
No, the tuple. The
Next
result.
will be 6 comma 3. Okay, great. Then
Okay.
It'll start from 7, then 7 comma 2, then 6 comma 3, then 5
5 and 4.
5, comma 1.
5 comma
5
1.
and 4, then 5.
6,
Then
3, 5, 2, 4,
5
2.
4 won't come, sir. 5 4 won't come because it starts from 3, no?
3 only, no,
Correct,
sir.
correct,
Don't
okay.
start from 4.
yeah,
It
okay.
won't start. So 5 comma 1 is fine, and then
No, 5,
4 comma 2.
Okay, yeah.
4 comma 2, I think. 5 comma 1, 4 comma 2.
5 comma 1 and 4 comma
4 comma
2.
2, and then 4.
So 1 will never come, right? Because 1 is just putting it
One
out
will
there,
be
right?
skipped from both the ends.
1 will
Act-
never come in both the both x and y, right? Because 1 is the last thing, and in range
It will
we
be
won't take the last one.
no,
yeah.
it will reach 1.
5, comma 1, it will be there. 5, comma 1.
5 comma 1 will be there. So why not let's just let's just
If
see.
you run these things, sir, in its polar.
Yeah, we just run and see. Okay, so we have got one answer. So 2 and 1 is also so you are saying that it will not reach 1, right?
It will not reach 1 because that's the last number. Sorry, my bad.
All right, let's.
It'll not
Okay,
reach.
see, the best thing to check is to do it. Okay, so what was it? Pairs. If someone can just speak out and like help me write the code.
Pairs equal to
X comma y.
for
then,
x in range
For x in range.
7 comma 1 comma minus 1.
Sheesh,
Then
7
for
1
what?
minus 1.
Yeah.
So see this y loop y for loop is a nested for loop within x. Okay, so first x will be fixed and we will traverse through y, then we will fix. I mean, yeah, of course.
Then y in range, you want the range for y?
3 1 minus 1 if x plus y modulo 3 equal to 0, that's all right. So let's see if it reaches 1 or not, and like, yeah, so it will not reach the last element, but if I were to do 0 here, then what happens?
We can't see your screen, sir.
Oh, I'm really sorry, I didn't share that thing. Okay, so if I were to, now I hope you can see. So I changed this 1 to 0. that way I can reach 1, and I have 5 1 and 2 1 as well. Okay, so if it were 1 here, God,
So it's 7 2 6 3 4 2 and 3 3. That's all.
7 2 6 3 4 2 and 3 3. Yeah, that's all. So yeah, see, I did this because you will definitely get a question with a floating function like this. Okay, that is why I just for your practice. I mean, it's very basic. It's not that complex, but still. And next one is this one. So yeah. So you know what, you have done the sets part in the thing, right? So U and V are sets that are disjoint. Okay. Which of the following expressions is true? So there can be one, there can be more than one.
So the piping operator is union, right? Piping
What?
operator is union.
This is union.
Is a union, and that is difference, right?
No, that is XOR. Sorry.
XOR.
I mean, XOR is exclusively OR, so that is something like a difference. So exclusive OR is only the unique elements. Okay. So
Okay. Yeah. Got it.
unique elements, as in union minus intersection is exclusively OR. See, because intersection means common elements, right?
B will be the correct answer, sir.
Which one?
B.
D or B?
B for Bombay.
B for Bombay. Okay, why don't you all write the answer here? Yeah, I will upload this video tonight itself, don't worry.
I think B only would be right because they are disjoint.
Yeah, so
the XOR, exclusive OR.
are you sure it's B?
I think it's B. I think it's B. Just a second. Let me check.
Okay, so see, I don't think it's B, so let's just...
Wait. No. Just a second. Sorry. So the union of U and V, and then if we XOR with V, I think then it will be U. I think it's C.
Okay, let's
Union
just
of U and
see.
V is the total set, and then if we XOR with V, I think we should get U. I think so.
See. So A and B are not joint. Okay, so that is what the question says. Sorry. U and B are. So just assume that U is A and this U is not U. U is A and B is V, and V is B. So just assume that. So what is the first option? U equivalent to V XOR U intersection V. Okay, so so first of all, intersection, there is no intersection here. Sorry, not intersection. This is union. So U XOR V is basically the whole thing. Okay, it's U plus V, because since there is no intersection, the union is and the XOR thing are same. So all the elements in U are unique, and all the elements in V are unique. So V union thing is not U. Okay, so this left hand side is basically U plus V. That is U union V, and it's not same as U. And here this is also the same, U union V. So that's also wrong, right? So I'll just change the color. Even that's wrong, because they are not the same. Third option is V XOR U intersection, this thing, right? So this thing is union, and V intersection this union is basically V, right?
So it's intersection, basically.
Not no, it is XOR. It is it is XOR. Oh, sorry, this is U. This is U. So
this should be U. Yeah, that's what I was saying. That if we take out the elements of V from there.
So third option is correct here. Okay. So So third option is what is correct.
Sir, can you please explain this part again? I'm a bit confused.
Yeah, sure. So you know what this thing means, right? You know what?
That
This is exclusive word.
yes.
Exclusive OR. So it's exclusively in only one set. That's what it means. Okay, it's exclusively in only one set. So if so, whatever is common will be in the intersection, and everything will be there in the union. So union is plus, intersection is star or into or cross, right? Sorry, I'm sorry. Union is or and intersection is and, right? So or you write as this vertical line. So this vertical line means a union. Okay. So here so since they are disjoint, that means there is no intersection here. What I said that this thing exclusively or is actually union minus intersection, because the intersection elements are not unique to any one set. I mean they are there in the both the sets. So union minus intersection is XOR, right? So since there is no intersection here, XOR and union are the same. Okay. So and if I do V union U plus V, it will just give me U plus V again. Okay, so I'll refrain from using plus here. Yeah. So it will basically give me U union V again, but U is not U union V, U is just U, right? And then I go to the fourth option, okay, just for completion's sake. So V union V is there, right? And U XOR U union V. So what are the what is common in U and U union V? All the elements in U. So that is what I'll remove. What is left? V is left. Is U equal to V? No, because they are completely disjoint, right? So U and V are not equal. Now let's go to the third option. Third option is V XOR U union V. U union V. So so the non-unique terms in V XOR U union V are whatever that are there in V. So we'll remove V, right? So what we are left with is U. Fine. So here, okay, sorry. Here, just see V and U. Okay, I don't need to do this. Okay, never mind. So U and V. So I hope it was clear. This thing, this V.
Yeah, you can proceed with A and B instead of U and V. That's fine.
Yeah, same thing. Right, so A and B are there. So A union B is this plus this, okay. So both the circles, since there is no intersection, and A XOR B is also the same, since there is no intersection, okay. So A XOR B and A union B here are same, that is the complete set. And from this, if I do B XOR A union B, so B is common in both, so I'll remove B, I'll be left with A. That's the answer for this. So yeah, so final thing for the day is for you to try this code. So do you want to try it first and then do you want me to explain, or we'll just start writing the code? What do you say? So I think there is a
This minimum number of cards, sir, would mean
yeah, wait.
can it be
Let
continuous?
let me
Yes,
just explain what you have to do. So write a program or a function to take in a string some word, okay, some word or some bunch of letters, and return the minimum number of cuts needed to make every substring. So see, if I cut a string, I'll get substrings, right? To such that every substring is a palindrome. So palindrome, for people who don't know, palindrome is what I mean. I can it's the same thing whether you read it from back or front. Okay, so for example, race car. So if I say RACCAR, or if I start from the left side RACCAR, I will get the same thing. Okay, so I don't need to cut this to get a palindrome. So I need 0 cuts to get a palindrome. So 0. Now let's go to ADDB, right? So DD is a palindrome. Okay, so I start from left or right. So see, if I just consider one letter, it's a palindrome, right? Because it's just one letter, right? So it is a palindrome, just one letter. So ADDB. So I have to cut here. Yeah, I have to cut here and cut here. So 2 cuts, right? And for magazine, I have to cut here. Since AGA is a palindrome, I have to cut here, 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 and here. That's 5 cuts. Fine. So I need the minimum number of cuts. So just keep that in mind. Let's say you hit one small palindrome, then you hit a larger palindrome which contains that small one. So then you don't have to cut the larger one. Okay, you will consider only one. So one of you can just explain how you will solve this. I mean, what is the logic that you have to use to solve this?
So, sir, I'll give it a try. So, if first of all we check whether it's a palindrome or not. So
Okay.
we can write a function which will actually either like recursively check it by chopping off the first and the last letter and recursively calling it to check whether it's a palindrome or not till the base case is reached, which will have just one letter. So if it's just one letter, then as you said, like it would be a palindrome. So if that is the case, then we don't need any cuts.
So see, doing it recursively, you will have to unnecessarily recompute a lot of things. So even here, we'll do it with dynamic. Yes,
We
slicing
can
is
use
what
a
we
reverse function.
Reverse slicing.
Yeah, no. See, that is just to check if the whole word is a palindrome or not. So to check if it is a palindrome
Just
or not.
reverse it and check whether the reverse is matching with the original word or not.
Yeah.
I have a suggestion.
Okay.
So we
Actually, this can be done using dynamic programming, but that will means I can't explain that.
I have a suggestion. Use 2 for loops. First for loop will start from the beginning only, and the second for loop will then keep adding letters. Okay, and if there's a palindrome found after adding all letters in length, then we'll take max as that palindrome. Okay, and then later again we'll go to the first for loop, the original for loop, where it will start uh, from the second letter, and then the next letters will keep going, and like that we'll find the maximum length of the palindrome that is there, and we'll minus it with the length of the string, and that will be our answer, how many cuts we need.
So since you
So
explained in
imagine,
air,
so imagine it this way: if it's A, D, D, B, okay. First for loop, I'll start from A, and then I'll keep adding, and then in the second for loop, it'll just keep adding. Okay, so it'll be A, D, D, B. They'll find max will be equal to 0 from the very beginning. We'll find no palindromes. What do you call that? String of the string is not equal to the reverse of that.
You want to
I'll
add
slice
one
it.
by one character.
Yeah.
One
Yeah.
by
Then
one character.
Forward
then the
coded
second
minus
one, when
one
it
would
finds
do it,
D,
I think.
and it will go to D, and it'll see that this is equal to the reverse, then it'll say max is equal to 2, because that is the length of the string where we got the. Are you following?
Yeah, I am somewhat following. I mean,
And then when we get the max, we'll keep it as max. If there's anything bigger than that, then the max will replace that. In the end, when we mean cuts, it means that whatever is the palindrome and everything else has to be cut. So it's the length of the string minus the maximum string in the name, that is a palindrome.
see,
I can try
I'm
it.
following, but the participants need to follow as well. And since you were, I mean, yeah, I didn't give you a platform to explain, so you just had to explain it in air. So what I'll do is,
I think what he's trying to say is that he starts from the first letter. So
no, no,
the first
yeah,
loop is like what I got. I mean, correct me if I'm wrong. So for I would start from zero to till the end, and then the next loop would start from the index I itself, right?
correct, correct, correct,
The next
correct,
one,
correct.
right? So yeah,
That's what you have to do, and you have to just keep
and we just
checking.
keep the track of the maximum palindrome
Yes.
till the
So
last.
whenever there's a check that this is equal to reverse of that, then whatever the length of the string we have right now is my max. So for example, if I take race car, it'll start from R and it'll keep adding until ACE car, and then straight away it'll see that the last one of it is a palindrome. Look, and then it will say that yes, this is the maximum. Max is equal to length of this. Then after going through all the other iterations, it will see that there is no other palindrome coming, or there's nothing else that is more than 8. Then it will come back and say uh, number of cuts is equal to length of string minus max, and it will become 0.
More or less,
Or
yeah.
else, like we can even check in first itself, like whether the initial string is a palindrome. If it is, then we don't need anything. Like by
That is
checking
on
whether
if
Yeah,
length
that
is
is
equal to
the
max. That is
that is
the
the first pass of the second for loop, right? Okay.
yeah.
Anyway, let's. I'll just write the code. So okay.
give us time to write it.
Do you think we have? I mean, no.
All right,
See,
sir. Sure.
yeah. See, you knowing the logic is like code. You see, once you know the logic, you can write the code, right? So
Was my logic correct?
more or less, I guess. So yeah, so first, like they said, we need to check if whatever substring we have is a palindrome or not. So first I'll just define a very small function. Instead of comparing again and again, I'll just say, right, so just define if it is a palindrome or not. Okay, so this pal, and input is my string. So it helps me to check if it is a palindrome or not. So I'll return true if it is a palindrome, right? So this basically says that this is equal to its reverse. So if this is true, then it will if this is valid, if this condition is satisfied, it will return true, else it will return false. Okay, easy.
Yes.
Yeah. So now our actual code. So
Can I explain the previous program?
previous what? Okay, never mind.
The above one, the pairs.
First one. Oh, pairs we just did. So I'll upload the video on YouTube, the whole meeting. So just please check, okay? Because
Okay,
pairs,
saved.
yeah, pairs. This pairs thing we just pairs. Pairs. Your friends will
Nested loop,
explain it to you later.
nested loop, and
No, don't. I mean, don't do it now.
okay, so
Yeah. So, so yeah, first of course we need a variable for the length. So I'll save that as n, and then so I'll create a table, but it will be better if I have a two-dimensional table, right? So I mean for each, I mean to just compare it with both the things. So this two-dimensional table will just say that if it is same or not. I mean if two 2D because see both the dimensions will be the letters only, letters of the word only, but to compare each letter with every other letter, I need to create a table that is 2D. So I'll just create the table that says all false. Okay, so I am assuming that it is not a palindrome. I mean there are only palindromes in the string are the individual letters. So I'll just say initialize this as false. Yes.
Any idea what is the pattern tomorrow and what are the important topics?
Yeah, I don't know, so don't ask that. Okay, I have told all that during that, so don't ask the pattern here again and again. Rough pattern is what I said, and also there in the chat someone has mentioned a previous year's thing, so just check that. For now I have muted that window, so I'll not be able to hear that. Right, so I'll initialize my table as all. So this table is n cross n, right? So I have to check every letter with every other letter. So I'm just saying that those letters don't match. So I'll just write false here. Sorry, false n times, and to get a table, sorry, to get a table I'll just, it is n cross n, right? So if I just do n into n, it will just be one long list with only false or false, but I need n cross n, not just one row with n into n elements. I need n rows and n columns. So I'll just write for I in range n, that's all. So it's running n times, but since I'm not using I here, I is just a dummy variable, just to say that I'm running this code, I'm running this loop n times. So see, first it just means that false into n is just one row. I'm writing that same thing as columns. Okay, so n rows and n columns. So since I'm not actually using I can just replace it with this. So this underscore acts as a placeholder when we don't really use the variable in the for loop. Okay, so it just says that I am running the loop n times. I mean the right. So yeah. So first I'll assume that only substrings are the letters themselves. Okay, so if I have a word, say word, okay, WORD. So W is a substring, W is a palindrome by itself, O separate, R separate, and D separate. So like that. So I'll just say I in range. Well, actually, since this is quite long, I'll just call it SPT, or I'll just call it PT. Okay, so my table where I say store that what letters match and what letters are palindrome or not, it's just called PT. So here only the diagonal entries will be true. Fine. Like I mean that I'm saying only the only matching letters are, see, so word is there, right? So word is there as a row and word is there as a column. So wherever W is there, it's true, else it's false. So it's like that. So I'm just assuming only palindromes that are there are the letters themselves. Okay. So then, of course, I have also said that. So that means the cuts that I need is the number of letters minus 1. So min cuts. So min cuts is what I basically want. So I'll initialize this as a list with n elements. Okay, and of course, so not end. So yeah, actually I'll call it end because will end be fine? Yeah, for I'll tell you why I used end. Okay, so see, end is basically I'm going from the first letter to the last letter. So end does not mean end here, but you'll know. Yeah. So this says that maximum possible cuts. Okay. So max cuts. Max cuts is where no no greater than one letter palindromes are there. So that's when we get the max cuts. Okay. Or so now I have end. Let's say end is now the sixth letter. So I'll go from the beginning to that letter to see if it is a palindrome or not. Okay. So that is why I have defined them as start and end. So end. So I'm just starting from the starting. So it doesn't actually matter. But if I so see, so a race car is there. So if I am at E, it will still say, I mean RACE right? So that A, if I am there and if I am not hit the R, so it will say I need many cuts, okay, because it's not a palindrome. So only R separate, A separate and all that. So only those are palindrome. Okay, wait, it will not say that because ACECA is still a palindrome. So it will say two cuts, one cut actually, yeah. But once that last R is also read, I'll again start from the beginning to the end. I'll see if it to the end means wherever I'm at currently, and I'll check it if it is a palindrome or not. Okay, so I'm at one point, let's say the sixth element. Okay, so I start with the first element to the sixth. I'll check if it is a palindrome or not. If not, I'll go to second. 2 to 6 I'll check. A yes means okay, fine. If not, I'll go to the third element. So I'll check from third to sixth. That I'll keep on doing that till I get a palindrome or till I exit the for loop. Okay. So that is the logic behind it. And then yeah. So how do I write that? So first I have to see that the first and the last element are the same. So start and end are the same. I have to check that first. Okay. So S. Oh my god. So S start and S end have to be same one, and yeah, and of course you have to make sure that start and end are not the same, right? So end minus start less than or equal to 1, or you have to make sure of that, or you have to see that if it is a palindrome or not. Okay, so I'll just see is pal okay, just give me a minute. Okay, so yeah, even I got confused. So yeah, the palindrome table was called PT, right? Yeah, so start plus 1 and end minus 1. So since I've already removed the first and the last terms, I mean, so they have to be equal, and rest of them also have to be equal. Okay, as in I mean this has to be true. Okay, true as in, yeah, because this particular element in this has to be true. Okay, so I enter the loop. Should I have used, okay. So if this is true, then I'll just change the thing to, I'll just, again so this this particular element in my table will be true. Fine. And of course I'll have to check if I'm starting from the start, right? Just let me write it, then I'll explain, because I'm thinking and speaking at the same time is slightly right. So actually I'm done with this here. So first I enter the loop, like I said, I'll whatever element I'm at, I'll check from the beginning to that element and see if it is a palindrome or not. Okay, so to do that, so I have not used this function at all here, this pal. Have I used? No, I haven't. Okay, but anyway, so where were we? Yeah. So if start and end are matching, I mean if the s of the start index and s of end index are matching, and yeah, they are not the same. I mean they are sorry, and they are so they'll match if they are same, right? Of course. So this is less than or equal to. So this can be true if either they are the same. Okay, so if they are the same, then we don't need to satisfy this. That means we are at the same element, right? And we can't go. So start can't be more than end. This makes sure of that. This statement, this statement or condition makes sure of that start can't be more than one, but start and end can be equal, right? So and so if they are equal, or they are just back to back. Okay, so if I have two letters A like that, that means it's true. So this need not be true. So in that in that specific block in the table, I'll write true. And but this need not be the case, right? I mean it need not be that they have to lie one after the other, or they have to be the same. So I'll check if this thing is there. Okay, so if in my table itself, if start plus 1 and end minus 1, so start and end I have removed. Now I have to check this start plus minus 1 and end minus 1. What I mean by that is, so for example, I am seeing race car. Okay, so R and R have matched. Now I have to compare A and A also, right? So that's why. So plus 1 and minus 1. So that's also true. So in my table where that so race car has 7 letters. So first and 7th are same. Now so in my table I have marked them to be true. Now I'll check if the 2nd and 6th are also same, right? So I'll mark that as well that way. Okay. So yeah, so it says that if I'm starting at 0, then the whatever the number of cuts I need is is of course 0. Else minimum number of cuts up to that point, okay, up to that point in the word is minimum of either that or this start minus 1 plus 1. Okay, so you will understand better if I okay, wait, how many spaces here? 2. So 2. Just print this for debugging purpose. Okay, and return. So let's also try out an example. So input is okay, let's start with, okay, not race car, we will take some word which has a palindrome, but the word itself is not a palindrome. Okay, so ERE here is a it's not a word, but so my result is basically so what did I call this? Palindrome partition pal part. Input, okay, print. Last time I told you why I wrote f here in the beginning. Minimum. Okay, so let's see if you have any errors. Yeah, I'll unmute actually now, unmute the site so you can say some things. So see, I have RATERE. So if I had just 0, leave that. So if I had just R, then I don't need to partition it at all, okay, because R is a palindrome. If I have RA, I need to make 1 cut. If I have RAT, I need to make 2 cuts. If I have RATE, 3 cuts. RATER, 4 cuts. RATRE. So now it's so see that, so 0, 1, 2, 3, 4. Now I'm at E. So I'll check from R first. I'll see if it's a palindrome. No, it's not. I'll see if ATRE is a palindrome. No, it's not. Now from here, from T, nope. So from E I check and I find that it is a palindrome. Okay. So this min cuts has changed now. Minimum of 5, right, because end was 5, right. So when I enter the for loop, I say that it is 5, right. So when I enter the for loop, I say that the minimum number of cuts that are needed up to that point is the number of values. So I have initialize this as 5, then I go in the loop. So this if, so this will keep running till start reaches end, but if this if has this first start itself, so start itself matches with end, and if this holds true, then that means I don't need to cut it at all, right? So the whole word is a palindrome. So if this is not the case, then I'll go to else, and I'll keep updating the result. Okay, so yeah, so once I reach this E, yeah, so when I reach this, I say that ERE is a palindrome. So up to there, I needed two cuts. So third cut will be this, right? This +1 is basically the third cut to remove that palindrome from the rest of the thing. So up to then, I needed two cuts, right? So I'm here. So when I remove ERE, I've gone here. So up to there, I had two cuts. So this third cut, I'm making to partition this last palindrome. So 3. Okay. Any? Yeah, Mr. Mohammed, you can.
Yeah. Sir, I just wanted to know whether like the when we are determining the palindrome, so do we need to cut anything in between the letters? Like say suppose if something would have been there in inside ERE, let's say suppose D, EDRE, and we see that after removing D we have ERE. So do we do that also? Or we just take the contiguous collection of letters as our palindrome?
We can't check separate letters, right? We can't split letters, right? I mean, if I have.
No. What I was saying is that either we move forward and check whether we are getting any palindrome as a substring, right? As a substring, correct?
Yeah, palindrome. Yeah, we are checking that way, right?
Yeah. What I was saying is that do we even do like something like within that particular string, if we can remove anything, then can we get a palindrome or not? We don't do that.
We don't have to do that, right?
Okay.
I mean, we have already considered that possibility. So if that is a palindrome, I mean, if you see, we are not jumping at the maximum length first, right? So if it is a palindrome, then it has been recorded. Okay, I think Prashant has a doubt. Prashant A. No doubt. Okay, then I'll lower your hand. So was this somewhat clear, or yeah, please go on.
Sir, can you just share this code? I will have to go through it. I could not make it out. I was thinking like, can we have I mean, in the dynamic table, can we have it populated in terms of numbers, so that like we have the length of the longest palindrome, and we just take the max of the number in the table, and we subtract it from the string from the length of the string to get the number of cuts.
Okay, so wait.
Can we do that? Like I was just thinking, is it possible? I don't.
Come again.
I was not.
Come again.
In the 2D array itself, if we populate the 2D array with numbers, right?
Okay.
And then from that, the max of the number would denote the length of the longest palindrome.
Yeah, you
right?
can. Yeah. That is one more way actually. I mean, you can try to do that.
Is that possible? Okay. I'll try to do that. Can you just share this code, sir?
Yeah, I will share it in a while. I mean, before the session ends, I'll share it. So just give me a minute.
Just
Okay.
one question. So I understood you use dynamic programming here. I did it brute force of n square.
Brute force will not yield n square. See, recursive thing will yield n cube. Dynamic is n square, and brute force is more than n cube.
Oh no, I did not. My brute force was just 2 for loops. I'm comparing. I'll show it. Maybe it will help.
Yeah, maybe you can present your screen. I'll just stop.
No, I'll share it directly here. It's fine. It
No,
works.
no, no, no. Just.
Okay, I'll see if I can share it. Can I share? Right.
Yeah, you can, you can, you can.
No, I don't know how to share here. 1 second. Yeah, I got the button. Mm, this is my code. It works. Can you see?
Okay. This is quite a short code. Okay. Oh, sorry. Min cuts is actually.
The min cuts is before. This is mine.
Oh, right, right, right. Fine, fine, fine. Okay, can you run it? Magazine
Yeah, it works. It works. So
is 5.
magazine is 5. Uh,
Bookkeeper, just try. Wait.
book uh, keeper. Is this a spelling?
Yeah, yeah. 7. Yeah, so 1, 2, 3, 4, 5, 6. 6. I'm getting 6. Let me just try in my this thing, bookkeeper, if it is 6 or 7. Oh god. Oh wait, mine is saying 5. 1, 2, 3, 4, 5.
Or rather, might not be correct.
No, no, no.
Mine
You're,
work with race car and ADDB. So, and magazine as well correctly.
okay, wait, magazine. Oh yeah, my screen is not shared, right? Yeah. Magazine is 5, right?
Yes, magazine is 5 for me.
Can you check with deafening? Okay, not deafening. DEAFA.
What if the palindrome is in somewhere in between the string?
DA
DE. Okay, wait. I'll I'll share my screen. Okay, yeah, you right. DEAFAT.
F
80, not EAT. Like FAT. DEAFAT. Yeah, it's not a word, but so still. Yeah, okay, fine. Even that is fine. So 1, 2.
So
Okay,
I
yeah.
know what my code is doing. What it does is
AFA.
it takes from the middle, whatever it is. It will not take E. It will not say I'm cutting E and then it will be a palindrome.
Oh, right, right,
Yeah,
right.
AFA. Yeah, AFA is fine. AFA.
It
It,
will
it
catch
returns
AFA, but it
AFA.
will not. But what it will do is it will take from here and it will keep going up, and it will take here and keep going up, and then from here it will take and keep going up. It will not cut anything from between. I understood most.
But
Yeah, of course.
what
That's
I was
also.
thinking over here is that when it moves forward and it moves to the end, right, to check whether check is equal to check a reverse, right? So in that loop, it's okay. It's again like looping word by word. So then it's fine. So for
Mhm.
every word, it's checking.
Right, right. Okay, then. I hope this was somewhat useful this session, and all the best for tomorrow's exam.
So can you share this code, please? What you have shared for
You,
dynamic programming, and also like, is it possible to do it like that? Like if we have the table populated with the length, like say suppose we're using some dependencies.
see, everything is possible. Okay, I mean, you wait. I'll just share the code.
Sure.
Up till where is it coming? You just let me know. So it is coming till PR. What is
PR,
PR?
yeah, yeah, PR print. I think something you're printing, maybe.
Oh, print min cuts. Right. Yeah, yeah, I was printing min
Yeah.
cuts. So ignore that. This last line is just return. Return this thing. Okay.
Okay.
Yeah, guys, please help him out in the chat. Someone has a doubt. So,
Well, at least I don't know whether they'll ask us to code the exam. That's questionable.
this was just for like basic. Yeah, what I'll do is I'll also copy your code just for my reference.
So I understood what's wrong with my code, but are you talking about my code?
Yeah, yours.
Sure.
Oh, you got where the bug might be, or
Yeah, no, it's not a bug. So what I did is I did not pick out letter from each place. What I did is I'm taking it from the beginning, going till the end, and then if I'm not getting, and after that I'm checking if there's a palindrome, and then I'm again restarting from the second letter and going right till the end.
right.
And like that, I'm checking if there's anything that is close to a palindrome. Anything that is a
But
palindrome.
it does return the ones that are in between, right? I mean,
Yes, it returns the ones in between.
yeah, I think
Correctly.
then it's fine. I think then it's fine.
Was that the requirement? Only the ones in between and not.
No, it should. I mean, no. See, cuts. It should also cut the what is it called? Also, individual letters, right? So if I have
Mine does not cut individual letters.
no. What is the output you get for the word WORD?
Word. That's a good question. Word. It says 3.
Yeah, 3 is fine. And what do you get for palindrome?
Palindrome. 9.
Yeah. Then it is correct. Then it is correct.
Okay, then
I mean-
please. I'm sending DefPal again in case you missed it.
No, I have it. I think you can. Yeah, fine. Do it. Send it again. Few more outputs and inputs for this program. Yeah, sure. I'll give few more outputs and inputs. Share this again. So I have. Yeah, I have also copied a code here. Gaurav, if you can see it. Okay.
Yes.
Yeah, so yours, yeah, you don't use dynamic programming, so that's also. I mean, yeah, of course, you don't need to use it. Just to
It
say
will
that,
take me a while to wrap my head around dynamic.
yeah, that is somewhat. But you're also not using recursion, right? So then,
No, I'm not using
yeah, so then you're not wasting your steps. So Shenbagavalli, I'll just. So give me an example of a word. I'll just type it in for you.
So for me, race car worked. But
No, not you. Someone in the chat has asked this thing, right? Can you give more examples? Programming. Yeah, sure. I'll use programming. So see 9. So how so P no, R no. I mean, see there is only double M here, right? So I'll make 1, 2, 3, 4, 5, 6, 7, 8, and 9 cuts. So see won't get cut. There will be a cut everywhere else. Okay, so if I change it to A, then C, then what happens? So this AMMA has become one palindrome. Okay, so 1, 2, 3, 4, 5, 6, and 7. Only 7. So if I change this to, let's say, N. Oh God. That's a G.
I didn't check my code, but if it's just looking for palindromes in the middle of the entire thing, it will work fine.
Right. And then, yeah, even now I need even less number of cuts. Right, so 1, 2, 3, 4, and 5. So GAMMAG is a thing. So now I'll just remove this. I'll write pro here. It should give me more or less the same answer. Right, so gamma. So this one first cut, second cut, third cut, fourth cut, fifth cut. Okay, so it doesn't have to be in the center, middle, or wherever. It can also be at the start or the end.
One question: can you take the entire? Go back to programming.
Okay.
Take from cut from N to O. Cut from N to O.
Okay.
Put in the middle of the two M's.
Then I don't think any palindrome is there here.
No, that's why I want to check.
It's 10,
Okay,
right?
it doesn't. Okay, fine. Then my program will work. I know that now.
Yeah, yeah, okay. Cool, cool, cool. Alright, I think. Oh, sorry, we are using this DP table only in if condition. We could have avoided that well. Yeah, see this DP table you are saying I'm only using in the if. Okay, wait, which DP table from the this current question or the PT, right? Yeah, okay, fine. I'm using it within if to update it, right? To update the values, not it's not like just within if. Within if means within the for. I'm using this if to so I started out with false, false, false. Okay, so just to wait. Here, so I'll insert a table 5 into 5. Right, so this is W O R D just assume even this has the O R D Y. Oh god, this won't work.
I think you have to insert
One more
extra
column, yeah.
column.
Column, yeah. Insert. Oh, sorry, table design. Insert right. Thank you. So this is yeah. So W O R D and Y. So remove this. So yeah. Then now I have to also insert one below. Right.
One row also, yeah.
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 So remove this.
Yeah, you start from there.
Yeah. Okay. Great. So see, now I started with false because I said that nothing is matching. Then I said only the diagonal ones will be true. Okay. So in my dynamic table. Now I compare and I see that which is false and which is true. So that is so this table has been initialized like this, saying that rest of the entries are false, only the diagonal entries are true because W are same, O are same, R. So this I can't actually. This is actually a bad example. So I'll use O here, and I'll use W here, right? We, fine. O and W. So now I can see that even this is true, O it's false, this is true, this is also true, and this is also true. So first I am here, okay, so here I am actually, so one more way to understand this is, I am here, then I go to, okay, not here, I am here. See, one way to traverse would be like this, then one more way is to do it like this. So see, so here start and end are matching. So I see that these two are same, then I do end -1 and start +1. So start is this and end is this, just assume. So I'll see if it is also true. That means I can check again, true, true, true. So if all these are true, that means this whole thing is a palindrome. If only these two are true, then no use, right?
So then we have a length of 2, right?
No, no, no.
So WO and WO from the.
Oh yeah, right, right. Sorry, sorry. Yeah, see, if these two are true, then even these two have to be true. So for length of 2, I have to check here and here. Can you see my pointer?
Yeah,
Yeah,
yeah.
for length of 2, I have to check. So if these two are true, then these two will be true, right? Because I'm comparing this and this. So if this is t, this has to be true. So it's like that. So I'll stop here. I mean, I'll stop it here. I mean, I'll just assume if that they are also matching. But in between this traversal, if I hit a false, then my whole thing is gone because I've got some wrong argument. So just because they are matching, the whatever is between them also has to match, right? So this was a very vague way to put it, but anyway. So all the best for your all the best for your exam. I mean, I'll upload the video tonight itself, so you can see. And if you have any doubts, the forum is always there. I can answer you through the forum. So thank you.
And so my code, just one question, my code works, right? Like in the end of the day.
Yeah, your code. So where do I input? Oh, yeah, I can
just put in defined pal. That's it.
Yeah, it works. It works. I think it should work. I didn't check the whole code, but but I just wanted to include dynamic programming. The
you're
code
right.
might
Yeah.
no, the code might look. Is there anything like lambda function in Python? Oh, we had a whole session on lambda function, I think. So I think one of the weeks I introduced you to lambda. Week 3 or something, I wrote a function that has lambda. So I also said where we use lambda and how we use lambda. Okay. Whether we program code, please tell. Everybody wants to know the pattern. 2 minutes brief on lambda. Hey, just skip to that on YouTube. Just I think it's week 3. Okay, so just go there, and I have also so timestamps are there. Okay, just go to that particular timestamp. I have explained it for 5 to 10 minutes. Just watch that because 2 minutes will not do justice to lambda. That's why. So, and okay then. Okay. Good night and all the best.
You take care.
Okay then. Bye.
Thank you, sir. And so, sir, yeah, for tomorrow, like, what could be a good ideal marks?
Don't ask me about marks and what you need, what you don't need. Don't. I mean, don't ask that. It's all I'd say.
Okay.
Okay, thank you, sir.
Okay, sir.
Bye.
Thank you.
Okay then.
Thank
Bye,
you.
bye,
Thank
bye.
you. Thanks for the session. Nice
Okay.
session. Please upload
Thank you, sir. It was a
the
nice
Yeah,
time
sure.
being with you, sir.
Okay then.
Thank
Bye.
you. Thank you. Bye bye. Have a
Yeah,
nice.
thank you, sir.
Bye, sir.
Bye.
Thank you, sir.